Hi, everyone. Good morning. My topic for today is state maintenance with Redux in a multi-layered JavaScript application. And I know as soon as I say that, most of you will be like, what? Trust me, when I submitted my proposal to JS channel, even my expression was like that. I was like, really, have I done something like this? Is it that complicated? But trust me, the topic sounds way more complicated than the actual implementation, and you guys will get a hang of it pretty soon. So just bear with me for a little while. I'm Varsha, and I work for Flipkart Internet Private Limited. I'm a huge tea addict and a shopaholic, and I'm still learning JavaScript and very passionate about the language. Now, before I can deep dive into the topic and kind of explain how and why we went about doing things that we did, I would like you all to know about the use case that we had. So as I told you that I work for Flipkart. Now, while working for the customer experience team at Flipkart, we came across a very unique use case in the sense that we had to build a unified CRM application. Now, when I say that statement, there are two keywords to it. One, unified, and two, CRM application. Let me tell you a little bit more about a CRM application. What I'm trying to say is that when you call Flipkart, right, there is a customer care agent who picks up your call and he answers to your query. You ask about your order details, you ask about any other payment details, or you ask him to perform an action like cancel your order or whatever, and he does so by looking at a web application. Now, this is the application, this is the CRM application that I'm talking about. When I say unified, what I mean is that Flipkart, as of now, has acquired a lot of companies in the past, as most of you might know. So we have eCart, PhonePe, Myntra, Jabong onboarding with us. Now, when I say that we wanted to provide a unified platform, what I meant to say was that all these CRM activities, right, they had to be provided in the base application or the main application that we were trying to build, right? So there were some capabilities of the platform that I was talking about. Number one, calling a customer. Right? So the customer care executive, be it for any organization, Flipkart, eCart, PhonePe, he would want to call your customer, or the customer would want to contact him, right? So this platform, this main application that I'm talking about, needed to provide such an ability, so that the customer care executive could call the customer and vice versa. And we could open a session using WebSockets or whatever. The second one was writing an email to the customer, right? So the interaction medium can be via call or via an email, right? The customer can write an email to Flipkart or PhonePe and vice versa. Similarly, chatting with the customer is another medium, right? So I hope you get the hang of what I'm talking about. There are these various channels of interaction that I would want to provide in my main application or the base application that I've been talking about, right? One other example that I would like to give is that each customer contact to our customer care executive could be like a session, right? So in the session, the agent performs some activities that is recorded in our backend, and we have some kind of data going on over there. So this is another capability that I'm talking about, right? So this main application, the use case for this main application was to provide such a platform that all of these organizations that were onboarding with us or might onboard with us in future could have all these capabilities in a single application, right? Now let's talk about the differences now. All these organizations that I've been talking about, now they have a different set of customers. For example, Flipkart might be serving to, say, your order details, but eCart might be serving to your shipment details. Similarly, PhonePe would be serving to your payment details, right? So you see what I'm talking about. There are these common things that we want to provide as a platform to all of these organizations. But there are also different things, the individuality of these own applications, right? They also want to retain their functionalities, their own individualities, right? So let's see the differences now. First thing is the layout difference. So so I spoke about the main application. Now I want to integrate these sub-applications on top of this main application. Sub-applications being Flipkart, eCart, PhonePe, etc. Right? So say sub-application 1 has view like this, where you have one row at the top, second row at the bottom. The first row is divided into 3 columns. Maybe when you select something, the details come up in the second row. Now in the sub-application 2, the layout is completely different. It has, say, 3 rows. The top 2 rows have 2 columns each, and the third row is just 1 column, and when you click on something, the details get loaded. So this is the basic view difference that might be there in the sub-applications that are being loaded into my main application. The second kind of difference that I'm talking about is the functional difference. As I explained, that all these customers are different for each of these applications. Like Flipkart might have different set of customers, eCart might have different set of customers. So basically, sub-app 1 would want to show you the order details and would like to perform actions like sending an SMS to the customer, while the sub-app 2 would like to show shipment details and would be performing actions like cancel this shipment. Right? So these are the basic functional differences of the applications that I'm talking about. The third kind of difference is the non-functional difference, which was a big differentiator for us. So basically, when I told you that these entities got onboarded with us, what I'm talking about is different tech teams. For example, in one sub-app, in one entity, the engineers decided to go ahead with React, to build their application with React, right? But in another application, it was not that let's say it was not that big a use case that they wanted to go ahead building it using a framework or a library, and they were pretty comfortable, coding in vanilla JavaScript, right? So this was the big differentiator for us, because our platform needed to onboard applications that were not just on the same tech stack, but might vary too, right? So this is the differences of the applications that I'm talking about. Now, for those of you who have snoozed off by now, I would like to tell you a short story, and I'm going to be a little bit dramatic because I just love drama. So in a land far, far away, let's call that Ekma Island, there lived a family of 2, React Senior and React Junior. React Senior being the father, React Junior being the son. And everything was happy-go-lucky for them, right? Their communication medium was easy, they could interact with each other. React Senior used to drop React Junior every day to the school, get him back, feed him, bathe him, clothe him, and everything was just fine. The house was nice and tidy and clean. And then war happened. And like any other war, this was not good at all. It was tragic. Like the invaders came into the island, they attacked, and the Ekma warriors fought bravely. But alas, like every other war, the end was still not happy. And React Senior was so overwhelmed with emotions that he decided to adopt 2 little girls, Vanilla and jQuery. Now, these little girls were adorable. They were adorable, really. So now, in the house, there were 3 people, 3 kids, React Senior being the father, React Junior, Vanilla, and jQuery. Everything was happy, everything was nice, everybody was tra-la-lying around the Ekma Island. But who knew this was the calm before the storm? 3 kids in one house. It was nothing less than a mess. These little pranksters made React Senior's life hell. There was this one instance where jQuery went around peeing all around the house. Yeah, sad. There was one instance where Vanilla actually wore React Junior's clothes to school, and there were other mix-ups like dirty laundry getting mixed with washed clothes. The house was a mess. Toys were like everywhere. Nobody knew what to do. I could show you some examples. He's trying to find his acid. I don't know what he wanted to do with the acid, but he couldn't find his acid. Here's jQuery, who couldn't find her glasses. And the baddest of them all. One of the little pranksters actually mixed salt instead of sugar in React Senior's coffee. Seriously, not cool. Nobody messes with this coffee. So basically what I'm trying to tell you with this short story is that this is the current problem with our large-scale application. It is hard enough to manage state in a single application. Now, when you onboard sub-applications on top of your platform, it is even more difficult to manage state, right? The second kind of problem that I'm talking about is how do we even perform routing in such scenarios, right? So basically, there is a main application, and it has some base routes. For example, as I told you, that there is a basic session that is going on between the customer and the customer care executive. Now, this session is a route which actually loads a component onto your web application. Now, the sub app also has some basic routes that it also wants to render, perform some actions or load some component. How do we even club these two routes together, the main application and the sub-application? And the third, and the most important part, how do we even bridge these two applications together, right? What is the interaction medium? How do these two applications even interact with each other? So that is the third problem. So I guess these are the three major problems that we faced while building such a large-scale application. So let's go back to our parallel world. In the short story, what could React Senior do? Like, everything was a mess. The state of the house was a mess, right? What could he have done except hire an external help? And enter our favorite and lovable butler, Redux. Okay, I was expecting some applause there, but it's fine, it's fine. Yes, so Redux. I'm not sure if I'm the right person to be talking about Redux when we have Andrew Clark, the co-creator of Redux, sitting right there. So guys, if you have any questions regarding Redux, please don't ask me. This is my first talk, and I'm super nervous. Please shoot all your questions at him. I hope that's fine with him. But I'll anyway try to tell you what we did with Redux. So basically, what is Redux? It is a predictable state container for your JavaScript applications. That is the major definition that I read in the documentation as soon as I opened Redux. What it does is that it maintains the state for your JavaScript applications. That's obvious. And it works on three major principles. One, that it has a single store that is kind of holding all your state of the application. And the second part is that whenever you want to change the state of the application, second thing is the state is non-mutable. As in, whenever you want to change the state, you kind of ask or dispatch an action that says, yes, I want to perform some changes to this part of the state. Please let me do that. And there are these reducers. There are these pure functions that work on their respective slices of the state and change the state and give the new state back to your component or to your view layer or whatever. So basically, when I think of reducers, I immediately get reminded of Despicable Me. So there's this Gru, and he has a set of minions, right, working for him. So when I think of reducers and when I think of Redux, I think around the same architecture. Like Gru kind of gives an order to his minions, and minions immediately start working and immediately start working on their part of the state, and then the state gets combined and rendered. So when I think of that, I immediately think about minions. I found this great example of how Redux works. So basically, if you can see, there's a view layer here. I think I'm going to share the slides with you because it's not pretty clear. I wrote the URL over there. But OK, so the view dispatches an action, and it goes to the store. The respective reducers who are working on their part of the state work on that state. Then the state gets combined to a single state tree and again given back to the view. So that's the working. So the Redux store APIs. Basically, what does this Redux store give us? It gives us 4 major APIs, but I'm not going to talk about the 4th one because it is pretty advanced, and you can read it in the official Redux documentation. But these 3 are the ones which we majorly used and which we majorly came across to understand the concept of Redux in our kind of application. So basically, there's this dispatch. As I told you, if somebody wants to change the state of your application, it dispatches an action, right? And then these reducers work on that and change that part of the state. So the first API that I'm talking about is dispatch. The second API that I'm talking about is getState. Basically, whenever you do a getState from store, the store gives you the most updated state to you, right? It gives you the most updated state. The third API is the subscribe API. What does the subscribe API do? So it takes a listener, which is like a callback, right? And whenever the part of any part of state changes, it calls that callback function, right? Now, what it does not do is it does not automatically do the get state for you. So basically, you will have to do the get state to get the most updated state of your application. OK, so I would like to show you some code. And If you see my render function of this component, basically first I want to tell you how do we plug in Redux with a single application. That is a simple React application. How do we even manage state in that? So here you can see in the render function, there are two buttons that I'm rendering. On click of the first button, somebody sneezes, and on click of the second button, somebody burps, right? So once you click the button, you dispatch an action saying fetch medicine, right? Now this action I have written in an action creator here with type fetch medicine, and I send the problem, and the respective reducer that is working on it will check if the problem is sneeze, then it will prescribe you the medicine Sneezol. If the problem is burp, then he's having digestion issues and he would prescribe Lomotil. Let's see that in action. Okay, so the view is not clear. Better. So basically, if you see the header, this will be something that is constant across all our sub-applications or the organizations in our case. So this is the great roof that we all share. Now you can see there are two buttons, click to sneeze and click to burp. When I press click to sneeze, it immediately says, I need to take Sneezol. If you see in the console, the previous state had medicine store and no medicine as of now as the medicine. And when you dispatch an action called fetch medicine, the medicine store has medicine called as Sneezol. I don't think it's clear here. Okay. So then after this action is dispatched, the next state is Sneezol. Right? So this is how Redux works in a single application that is built in React.js. Now if you see something over here in the content class that I was showing you, there is something called as connect here. Now connect is nothing but a wrapper that is provided by React Redux. And what it does is it basically the subscribe API that I just spoke about, it subscribes to the store and listens to the state changes, and then it automatically gives the state changes to the component. The component is listening to those state changes, and it immediately renders whenever it is there, right? So basically, React Redux's connect wrapper helps us in kind of maintaining the state around this single application. Now let's see an example of an application where the main application is in React.js and the junior application is also in React.js. How do we even manage state then using Redux? Okay, so this is my sub-app React. And if you see the render function here, then I have just simply checked if the medicine that has been taken that has been taken is Sneezol, then yes, he has some kind of allergy or problem that I don't want, so please fetch me a handkerchief on the button click. Okay? And on the button click, you can see that there's an action that I'm dispatching to fetch handkerchief, and in the reducer again, I'm changing the state of handkerchief to true. Also, you can see that there is a connect wrapper right here. What it does is, if you see the map state to props, the function that I've written, it is also listening to the main application medicine store, right? It is also listening to the state of that main application, as well as its own application state. So basically, when you npm install this sub-application to your main application, what we really do is we create a single store. We combine these reducers together, we create a single store for all of these applications, and we create a single state tree. Now, branches of this tree can be subscribed by anybody, by any sub-app or the main applications. If we see it in function, then if I just change the path to, okay. I need to change this to sub-app React because I have 2 children. Okay, So as you can see, there's this common header here. Now this is the content of the parent app, still the click to sneeze and click to burp button, and that is a React child content on your right-hand side. Once I click to sneeze, the child component automatically got the state of the main application as well, and that is why it said fetch handkerchief. Now when I say fetch handkerchief, it says fetch handkerchief success. So basically, it's trying to maintain its own state, as well as it is reading from the state of the main application. If you see this, then fetch medicine, the next state, in the client state, handkerchief is false, but medicine is sneeze all. And in the next state, when I fetch handkerchief, then the handkerchief becomes true and the medicine is sneeze all. So this is how you manage state between two applications which are independent of each other. Now, mind you that the second application that I've been talking about, the sub app, it does not have a store, right? It just has some reducer pure functions that it also sends it to the main application via config that I'll be talking about later. Or we combine these pure functions together to create a single store in our main application. Right? So even if somebody wants to plug out this sub-application, he can easily do that, plug in a store and start the server, and that application will also start working independently if somebody does not want to use those common functionalities. Now let's come to the third and the most bad use case, I would say. So basically, I have taken the worst kind of example here. It's a badly written jQuery code. And I wanted to plug this also along with the main application and see how Redux can help me put this application together and still manage state. Now, as we all know, our production apps are never ideal, right? And I hope nobody says that my production app is ideal. So basically, that is the point here, that even if there is something that is badly written, and we are still able to manage state in such an application, then I guess it's a win situation for us. So let's just see how this works. Basically, in the document load function, I'm just rendering a div. And on click of that, I'm just trying to see what medicine had been taken by my parent application. So if I go to the main application and I change this again, I'm sorry, I've written vanilla. It should be jQuery. It's just that I was trying to implement this with vanilla first. Right? So this is the content, still the content of the parent app. And on your right-hand side, you can see a jQuery content. And when I say click to sneeze, it says sneeze all. And when I click this, what medicine did father take, it says sneeze all. Because since I passed my Redux store to this jQuery application, it was able to get state, and it was able to detect and show me what parent application had rendered or what state changes parent application had. So basically what you do, so the connect API that I was talking about in the other applications, it is taken from React Redux. But jQuery doesn't have something like that. It does not have the benefit of using the connect, right? So how do you even pass the store and get the state of the application? Now here is when the three APIs that I spoke about that Redux provides us comes to use. That is the raw implementation of these APIs. So basically what I actually do here is, as soon as I bootstrap my application, I'm passing down the store, which I'm going to tell you later how I pass it down. And I subscribe to that store, and I give it a callback. And in the callback, I'm doing nothing but getting the state of the application, right? Which I'm again using to render whatever medicine that parent application had taken, right? So that is how it works with jQuery and React. Okay, the next part. How do we even do routing in such scenarios, right? That was the second part of our large-scale applications. Now, what I'm expecting, what a main application is expecting out of a sub-application or a client application is a routing config like this. Basically, the sub-application, the child application need not care about what kind of routing is implemented. It just needs to give me the path and the component. Now, the component can either be a React component or it can be an object like that as we had used in jQuery. And my main application will take care of what to render what on what route when the route is given. As you can see in this, I have rendered jQuery Junior as the route, and it's rendering here, right? So how is this done? If you see this I'll show it to you in code, actually. If you see this, I have written store as create store from subapp.config.reducers. So basically, what I'm expecting out of a client application is to give me the pure function, the set of reducers in a config, and I'm going to create a store combining my main reducers and combining the child reducers and creating a single state tree. Then what I do is, in the routing, my sub app is also giving me a set of routes. What I'm doing is that if the child application says that it is a React application or any base application that you have started your code with, then I'm going to render the simple component that it has put on that route, or I'm going to create a bridge. Basically, I'm going to wrap a React component around this object that it has given, and I'm going to render it as a React component, right? I'm going to create a bridge to kind of wrap the vanilla or the jQuery component around and pass my store to it. So this is how the store looks like. I'm just combining the two reducers together. I'm combining the main application reducers, and I'm combining the client state reducers into one and making the common store. Now let's see how the wrapper looks like. This is how the wrapper looks like, right? It is just a simple component. It is just a simple React component that has a reference, and in the component did mount whatever vanilla or jQuery component I had passed. I call the bootstrap init function. I pass down my store. Then it subscribes to the store, and subsequently here the state changes. So this is the wrapper right here. What config am I expecting from my client? I am expecting a config like this, where he's giving me his set of pure functions, he's giving me his routes, and he's telling me whether it is in the base application state or not, whether it is a React app, or it is a jQuery app, or vanilla app. So I'm just expecting this kind of a config from the client. I guess this is it for me today, and thank you so much. We have started this community called Girls Who JS to encourage girls and women who want to go into the field. We want to make it easier for them because they're pretty shy. And it is started by my friend Pavitra Kodmat. And please share and follow. Thank you.